Greetings to you, ladies and gentlemen. Welcome back to Shexa's YouTube channel. And today I'm going to talk about computer engineering and more specifically about automation and control engineering. If you are new to this YouTube channel, please make sure that you subscribe. If you are an existing channel member, please like, share, comment, and click on the notification bell so that you don't miss out on any new video that we upload on this YouTube channel. So today we're going to talk about some few concepts about automation and control engineering. So this subfield or subdomain of engineering, it involves mechanics, electronics, information technology, computing, applied mathematical modeling, instrumentation, systems control, production control, and planning. And then it also have some automation in it. So what do we mean by all this? We mean to say, if you want to automate something, it might be something that is mechanically controlled, or that is mechanically activated. By mechanically activated, I mean its main function is achieved by mechanical movement, or it's achieved by physical motion, right? So you can actually automate something like that. For instance, let's say you want to automate you want to have an automated system that can actually move from one position to another. Definitely you will need some mechanics. You will need to join some items, and they need to move in such a way that they don't distract each other, or they don't destroy each other, or they don't disturb the movement of one item or one object or one device in that system. And for that to happen, definitely we need some electronics that's powering the movement and the motion of the devices in this subdomain, electronics. So definitely we need some electronics and some information technology. That is, definitely you will need some programming. That's part of the technology. You need to implement some technology or some techniques that falls under technology, that is information technology or computer science or information systems. You will need to implement some technology or some techniques or some principles of information technology. And then some computing, you need to do some processing to say, for this not to happen, let me check this. For this to happen, let me add this and that, so that I can come up with this. So that's the computing part, the processing. And then we have applied mathematical modeling. Then you can model before you come up with some physical systems, or you can actually come up with an automated system that can control some hardware, while the whole of that system is just software. We also have instrumentation. That's where we use some sensors, some electronic devices, some components and stuff. And then we definitely need systems control concepts, and then production control. That's where we say we are in a factory where we are producing some drinks or some beverages, or some food or some items that we need to package, and some items that we need to sell in bulk, and stuff. It also involves planning and automation. So all this automation and control engineering, when I look at it, I just think that it applies, or it applied to several other fields, be it in accounting, be it in agriculture, be it in education, it applies in several other domains or other fields of research or other fields where problems really exist. All right, so this is just a small annotation of what a control system looks like and the basic components of a control system. So the first thing is, before we look at this, let me just say we have a one, right? Let me have a drawing here. Let me say we have something like this, design or something like this. Right, and then that. Right, so in a control system, what we have are three things, which are number one, the input. We have input. So the input that we have there is feeding to a controller. So the controller is the one that is being fed, and then we have output, which is going out. So we have input in this part, the controller, and then the output. So these are the basic three items that you have in a control system. These are the three basic items that you have in a basic control system. All right, so in this case now we've added other nitty-gritties that are involved in a control system, and these nitty-gritties involves or includes set point or reference input. This is just an input, as I've talked about it in few seconds ago. Input, you say I want to give this, let's say you're cooking tea. The input that you put, the first is water, secondly you put water in a jug, and then you give the jug some input to say let it receive this voltage. That's the input. And then the input is definitely a plus, and then some error happens, and then we get the controller, and then the controller signal goes to the actuator. So the controller is triggering the actuator to do something, and then the manipulated variable is then sent to the process. So there we still have some disturbance, and the actual process gives an actual output. And then the output that we get, let's say we want to control room temperature. So if we are to control room temperature, we are saying we either have a heater, and a heater, we have two things, a heater and maybe a cooler, that is an aircon or a fan. So these two things are there to maintain a room temperature, to maintain a room temperature. So room temperature, we are now having a range. That's where we say set point. We set our temperature to a certain level. That's the input that we set. So if we set and then we check whether we are still within the range. If we are still within the range, what do? We do nothing, or we just maintain what we have. And then if we do not have, the controller is given some signal by the sensor and say the temperature is now too high. If the temperature is too high, aircon, please switch on to this level so that we drop down the temperature level. If the temperature is now too low, aircon, please switch off, and let's have the heater on so that we increase the temperature. So the actuator is the one that is now rotating the fan, or actually turning on the cooling system. Then we go to the actual process, and then up until we get to the output. If the output is now, so what is telling us that the temperature is now above the range or is within the range is this sensor that is giving us feedback to the input. So whenever we have feedback to the input, it's now a closed loop. If it's an open loop, we would not have this feedback sensor. We will not have this feedback signal from the sensor that is positioned at the end there. So a feedback signal can be a plus, a positive, or a negative feedback, depending on what happened from start to the end. So let me show you some typical examples on open loop and closed loop systems, and you shall give advantages and disadvantages of open loop and closed loop systems, and when can you use open loop and closed loop systems. So here's an open loop system. What is happening? This, maybe let's just say this is packaging. So the signal computer controller is now process robot system driver or actuator to process, and then it's now putting stickers or labels onto these packages. So that's what is happening over there. But consider that we remove one or two items from that belt. What happens? Here's another example. Computer controller is switched on by that person. System driver triggers the water pump to start pumping water and to move the sprinkler. And then the sprinkler is just watering the whole field, even on an area that is sufficiently, or that is got sufficient or enough moisture. It's watered. Then here we have another one. We are drilling some holes on these devices. But think about it. What if I remove this device? Or if I remove this device, or if there is no device, what will happen with the system? If it's not switched off, definitely it will try to drill some hole. Look at it. There's nothing but the resources are wasted. Right? That's an open loop. It's doing an activity given a time interval without anything. So here the advantage is simple to design, high repeatability and stuff. And here are the reasons or when to use this open loop system. Now let's add a feedback loop. We add a moisture sensor to our field, to our system, and then the moisture sensor is now telling us there is enough moisture at this area. Stop pumping water. Water is saved, electricity is saved, and several other resources are saved. Let's now add a feedback loop or a feedback signal to this system. We now have a speed sensor which is located there. When more items are coming, the speed is increased. When less items are coming, speed is reduced. Can you look at that? Look at that. Right. So in this case, there is no resource wasted. We are efficiently using our resources. So you can actually observe that in this system we had positive feedback and sometimes we had negative feedback in this closed loop system. So can you decide in your mind to say, when can I say I want to use an open loop system? When can I say I want to use a closed loop system? So find some problems that you can solve using open loop system. Find some problems that you can use closed loop system to solve such problems. So that's your takeaway for today. Thank you very much, ladies and gentlemen. Please don't forget to subscribe, like, comment, share, and click the notification bell. Enjoy the rest of your day. Goodbye.